we are going to create our first shallow neural network. So I am creating that notebook with my Python free version. I am naming it as shallow neural network. The first step, I am going to import the dependencies. Escape M to create the comments. I am going to import some of the critical dependent packages. Importing Keras first. The first load may take a little longer time. Let's wait. Okay, import is completed. We'll import the dataset first, and we are going to import our MNIST digit dataset. Next, we are going to import the layers. We are going to import the dense layer. For shallow neural network, we are going to have a fully connected neuron. So we will only require the dense network, dense layer. We need to import the optimizers as well. We are going to use stochastic gradient descent optimizer. For our testing process, we can bring another additional optimizer as well. So I am importing stochastic gradient descent, SGD, and ADAM both. We are going to import the model. We are going to use a sequential model here. We are going to import another utility that is called toCategorical. So this particular function will help us to convert our levels to a one hot mode encoding. That's all from critical components point of view, and we can import two of the side packages as well. I'm importing NumPy, SNP, I'm importing PyPlot, I'm going to import it for inline so that we can display the results in the notebook itself. The first step, I am going to import the data. So let's load it in a array. So I am naming it xtrain and ytrain, xtest and ytest. First, we are going to import the data. We load the data in xtrain, ytrain, and xtest and ytest for the images and the corresponding levels. The train will have the training data and test will have the test data. Let's load the data. They have made it very easy for us. The load function will return two tuples, and you can load it in this way, however I have mentioned here. So you can specify the specific location inside this bracket. During your first load, it may take a bit longer time as I already have downloaded the data, so it is a bit faster for me. So if you want to test the shape of these data, so you can do it. So we have a 60,000 images which contains 20 by 20 pixels. For this dense network, we are going to convert this 28 by 28 pixels two-dimensional array to a one-dimensional array which will contain 784 values. We are basically flattening that two-dimensional array to a one-dimensional array. So what I'm going to do, I'm going to use the inbuilt function reshape function to reshape the X train to 60,000 by 28 into 28. That will return is 60,000 by 784 one-dimensional array. I'm going to repeat the same thing for test dataset as well. I'm just going to change the name. Okay, for test we have 10,000. So let's see how it works. Okay, worked fine. So let's check the shape once again. So now we have a 60,000 by 784 array. So another operation we are going to do here, we are going to scale these data for our faster computation. So if you see one thing, the max value of this input is 255. So for this grayscale image, we have input of the pixel values which range from 0 to 255. We are going to scale it. We'll bring everything between range 0 and 1. So what we are going to do, we are going to divide both of these with 255. The max value is 1 now, and this will have a much faster calculations during training process. Now if you check the levels, it has a 60,000 values. So let's see. So you can see this 5, 0, 2. We have the actual levels. So what we want to do, we want to convert it to one hot mode so that we can get an array of 10 columns, and whatever value, actual value we have, the corresponding column will have only 1 and rest other columns will have 0. This conversion from actual values to this one hot mode would be done using this two categorical function. train equal to categorical y-train. So here we also have to specify the number of classes. Here the number of classes are 10. We'll repeat the same process. For tested as well. So conversion is done very fast. Check the shape of this. Now we have got an array of 10. Okay. So here we can see it was 0 earlier. Now we have 10 columns and the first column values contains 1, rest of them are 0. This type of conversion is important as we are going to use categorical cross entropy cost function. Now we are going to create our model. I am naming it as model. We have created the sequential model. Now we are going to add the layers to this model. We can do it using this add command in keras add function. We're going to create a dense neural network which will have 64 neurons, and for first layer we have to specify the input shape as well. Here the input shape contains an array of these 784 values to represent each individual pixels. We can specify the input using the argument input shape, and you can give it either within bracket or kind of in a list format. So I'm specifying the input here. Now I'm going to specify the activation function for this layer. For test, for initial activation function, I'm going to use sigmoid. You can specify through this argument activation. So our first layer is ready. So I'm going to use second layer as well. And follow the same strategy. We'll have 64 neurons. And for second layer, we don't need to specify the input shape. We just have to specify what kind of activation function we want to use. We are going to use the same sigmoid function. Our second layer is ready. Now we are moving to the last and final layer in this shallow network. So this would be a softmax layer. So we are going to add a dense network there, which will have 10 neurons, 10 outputs, basically to represent each of these columns. Our final labels contain total 10 columns to represent the one hot mode. That's why we are taking the final layer, which will return total 10 column values, and we are going to use activation function as softmax. Alright, so what I'm going to do, I'm going to put, I will adjust it later. So let's see our model summary, the shape of our model. You can use model summary. So here we can see we have 3 dense layers, and we are going to train total 55 parameters, which contains weights and biases. So what I'm going to do, I'm going to put these model initializations also inside the same bracket, so that we can maintain it properly. I'm recreating the model. Here is the model summary. We have 55 weights and biases to train. Before we proceed with the training process, we have to compile the model. We can compile the model using compile model function, models compile function. Here we have to specify the kind of loss function we are going to use. We'll start with mean square error. Mean square error. Later we'll play with this loss function to see whether there is any sort of improvement for if we use it as categorical cross entropy. We are going to use the optimizer SZD. In that case, we have to specify the learning rate as well. We are going to use a learning rate 0.01. We need to specify what kind of evaluation metric we are going to use. We are going to use accuracy. Later I will introduce you several other kind of advanced metrics as well. So let's see whether our model is being compiled properly or not. Okay, it was compiled successfully. Now we are going to train our model. We can do it using model.fit. First two parameters should be the data, features and labels, features and corresponding labels. We can specify the batch size as well. We have to specify the mini batch size. So I'm starting with 512. You can play with it as per your preference. Here the number of epochs I need for this model training. Initially I'm taking it 10 for quick training, we have to specify the validation data as well. Here we are going to use X test Y test as our validation dataset. We'll shuffle the records. I'm not specifying any seed in this particular case, but it's always good practice to have a seed value. And I will not set up the verbosity, I will take the default one, but you can check the verbosity or you can change the verbosity level. Alright, I'm starting my model training. It is very fast, it is taking only 1 second. Okay. So you can see after 10 epoch, model accuracy is 9%. This is lower than the by chance model accuracy. What we're going to do, I'm going to train it for a few more epochs. Let's take another. So eventually after approximately 30 epoch, we have gained around 15%. So one thing is pretty clear here, that the model training is happening very slowly, very slowly. So if we need to train this model a little bit faster, we can do, as of now, we can increase the learning rate. We'll try it in the next few seconds. Up to 60 epoch, we have reached to 14.71%. Alright, I'm just making the learning rate to 0.1. I'm recompiling the model. I'm retraining it. 21%. From deep learning point of view, this is disaster. It's nowhere considered at all that model is working. What we are going to do, we are going to change the loss function to categorical cross entropy. We are going to recompile it. What I am going to do, I am going to start it from beginning. I am going to start the kernel . And I am going to execute all the cells about this particular step. It's done. I'm creating the model and showing you the summary. I'm compiling it. Now I'm training it. Let's see how it works. Oh, in the first epoch itself, you can see the model has reached the accuracy of 47%. It's a big jump. And within 9 epoch, within 10 epoch, we have reached to 86%. So our shallow network is working. It has this 89% accuracy. Out of 100 we are able to predict 89 correctly. So one takeaway from this quick change is that categorical cross entropy is much faster than mean square error loss function. After 37, after 40 epoch, we have reached almost 93% accuracy. This is decent score, 93% accuracy, but this is only a shallow neural network. With this shallow neural network, we are able to get 93% accuracy. It's pretty good. Next thing what we are going to do, we are going to try the same model with Adam optimizer. You remember that Adam was the second layer optimizer, second order optimizer, which considers the momentum as well during considering the learning rate. So our model training is done after 50 epoch. It is able to get the accuracy 94.32%. Not bad. So now we are going to change it to Adam. Okay. I'm going to restart the kernel and I'm going to start all the cells. Okay, so the learning process is happening much faster now. It's a 90 after, in fact, 9 epoch itself. 92.5 in less than 50 epoch. We are crossing 93 now. 93.6 after 20. 94. And we are almost about to cross our stochastic gradient descent accuracy. And I think we have crossed it already within 30 epoch. We have reached 95.26, almost 95.3, 34 epoch itself. So pretty much with this 3-layer shallow neural network, we are able to get the accuracy of 96% somewhere. Come on, yes, we are able to get 96%. Okay, so our new benchmark is 96.5 somewhere within 50 epoch. Within 50, we have reached 96.4.